So hello, I'm David Majda. Welcome to my talk about TDD by example. So what I will do here is that I will briefly introduce TDD at the beginning, and then I will sit down and code a piece of real-world code using TDD, and I will show how I would do that. The real-world means that very similar code to what I do, what I will code is actually part of one of our products. So that's, it's not an artificial example. So if you are a TDD newbie, I hope you will understand TDD a bit. And I hope you will learn something by seeing somebody doing that. And if you already do TDD, then you can kind of compare notes and see what I do differently than you would, and so on, and maybe we can even have a talk afterwards. So our focus would be TDD itself as a technique, its mechanics, its workflow, how TDD-driven programmer thinks. It won't be tools, languages, very specific techniques. Basically, I will use Ruby and I will use Spec, but pretty much everything is applicable to other languages and other testing frameworks. Just to have an idea, who of you doesn't know Ruby, doesn't work with Ruby? So very little. So now I will introduce the TDD workflow. What is it? How we work with TDD? So the basics of TDD is this three things: red, green, refactor. So the idea is that the first thing you do when developing something is that you take a small piece of functionality you want to add and write a test for that, possibly in some framework or some place. And that test at the beginning should presumably fail because you didn't implement the functionality yet. Now, it's pretty important to run this test before you implement the functionality, because occasionally, surprisingly, it happens that the test doesn't fail, which could mean several things. Most often, it's that you already have the functionality implemented in some way you didn't think of, or maybe you have a bug in the test, so you did something wrong there. So that's the red part. You will write a small test testing, exercising small piece of functionality which doesn't exist yet. The next step is the green. You will write simplest code, the simplest code you could imagine to fulfill the test, to make it pass. At this point, your goal is really to make the test green. You don't care that much if the code is fits the overall structure, if it's the best code possible, and so on and so on. So that's your goal, to get to the green state. Your tests are passing. And once you are at this state, you do the first thing, refactor. So you look at what you just wrote and think, does it introduce any duplication? If so, then maybe introduce some abstraction, extract some method or whatever to remove the duplication. Does it fit together? Well, maybe there is some class that needs to be extracted, maybe the responsibilities aren't right, and so on. So you check for these things, you look for the code smells, and you refactor. And while you refactor, the tests should still stay green. That's important. Now the refactoring step is one that's often forgotten. People often go to the green and then continue. So please, when you are doing TDD, don't forget about the refactoring. Now, when you've done these three steps, you basically go back to the beginning. Take another small piece of functionality, again write a test that shouldn't pass, and go through the loop again. When you are doing TDD really by the book, you you do this loop, say, 10 times an hour or something like that. So you really go by very small iterations, and you go very fast and having very fast feedback. So why would you want to do that? Why would you want to develop in TDD style? For me, the primary benefit that TDD gives you is freedom to do changes. I'm pretty sure everyone has worked with some code which just the idea of touching it was like scaring you, because it was ugly, it was something that you know that is likely to break, maybe you didn't understand it completely, and you just didn't want to touch it. Maybe nobody even in the whole project wanted to touch it. And whenever you have tests backing your code, and whenever the tests really capture what the code is supposed to do, you don't have to be scared changing anything. You have a freedom to change, run the tests, and if they are green and if they are well written, there is very high probability that the code is still working properly. So that's, I would say, where the test-driven development or writing tests kind of changed software engineering a lot. Because before people were doing this, the state where you were afraid to modify any code or some code was normal, and was kind of the idea that what hasn't broken, don't touch it. If it works, was normal. Today it's not normal. Number two reason why TDD is useful is increasing quality of your code. In general, when you write tests, you want to test small isolated pieces of code without some complicated setup, so on. So that naturally leads you to write a code which doesn't have dependencies on some global state, explicit names its dependencies on other objects, its collaborators. It doesn't have too many of them, and it leads you to methods which don't do too much, so they are easily testable, classes which are small, and so on. So all these things are in general good. So on the other hand, when you do the TDD development and do all these things, you sometimes end up with designs which are kind of more complex than they would be without TDD. And there is a lot of discussion currently going on about that. So I would say that there is a strong correlation, at least in my experience, between good code and easily testable code, which TDD leads you to create. But I wouldn't say there is equality there. So, number 3 reason why to have tests and do TDD is that you reduce number of bugs. That's kind of the most obvious reason, but in my view, it's like the third most important. So yeah, I have, on many occasions I wrote some code which I thought that would fulfill the test I wrote just a few seconds before, and the code failed. The test didn't pass because I did some stupid mistake. And if I didn't have the tests, maybe I wouldn't catch this mistake, because often this was some edge case somewhere and so on. So, and again, when doing refactorings, there is often, you often introduce bugs because you change something which you shouldn't change. And TDD kind of prevents that. Number 4 reason for using TDD is that it allows you to have an executable specification and documentation of the code. So if you go to a new code base which is well tested, you can just have a look at the tests, and they describe what the code does. If they are well structured, if the names or descriptions in the tests are meaningful, you will be able to learn the APIs and purposes of the classes and so on by looking at the documentation, we will see that how for example, Spec allows to do that very nicely. And the advantage of this executable documentation and specification is that it never goes out of sync with the code, which is unlike most documentation. Because if it went out of sync, you would get failing tests. And the last reason I see for using TDD that it leads to less debugging in general. Because TDD leads you to work in small iterations. So whenever something isn't working, in 99% of cases, the cause is in the code which you just wrote or modified. Of course, in the 1%, there you just uncovered some bug which was there somewhere from the past and just wasn't discovered. But in many cases, the bug will be in the problem will be in the code you just wrote or changed. So you won't have to do deep debugging to find the cause. Okay. So that was the why. Now, you might ask, okay, so if I'm starting always with a failing test, that means I shouldn't write a line of production code without test, right? So you may think that's ridiculous to some degree. So do I have really to test all my getters, all my Rails model associations, and so on? So people often ask that, and Kent Beck, who kind of invented TDD, has a great answer. He says, test whatever you think might break. Which means, do I think I really screw up a getter? No. If I'm not, that's not the place where bugs hide, which I tend to screw up. And if I do, it will be discovered anyway very quickly. So I won't test stupid getters. I won't test model associations. But model validations, with some regex possibly, yeah, I will test that because that's a place where bugs will hide very easily. And I think I may screw up it. So there you want to be a little pragmatic about testing, what to test and what not to test. Another thing is what kinds of tests you want to write. So in my experience, I write several kinds of tests. Usually I write tests for the normal cases. They are pretty easy. Then I try to find the edge cases, because there is where the bugs usually hide, and explicitly test for them. All these tests usually are very minimal, but so I sometimes add kind of a complicated test, which tests several parts in interacting together. So we will see an example after a few minutes. So the idea is that sometimes the things that are tested in isolation don't work together when combined that well. And another thing which I tend to test is error handling. That's often forgotten and often done only implicitly. So it's good to kind of specify that in test what exactly should happen. And one kind of a note is testing of whatever occurs in sequences or in lists. So there are often operations on lists which kind of depend on the number of items in the list. Imagine that you want to say transfer a list into an English sentence, so you want to use commas and end before the last element. Yeah, so there are many instances of similar things. So what I found useful is usually to test 0 element list, 1 element list, and 3 element lists. That's my usual use cases, test cases for anything working with lists where the code is somehow dependent on the number of items. So that was introduction to TDD and to its benefits. And now I will sit down and code a little example, and I will try to explain everything what I will do. So, first, my setup. I have a terminal where I will run Spec, which is a testing framework for Ruby. And I have my text editor. What I have here is on the left, I have the class which I will implement. Just ignore the text for a while. And here I have the spec. This is my usual setup, that I just have a split screen and working with the tests and the tested code at once. And it allows for fast switching between writing the tests and writing the code. So it kind of enables the short feedback cycle, as I talked about it a few minutes ago. So what we will implement. One of our products stores information about systems, and it stores it in a JSON format. So imagine something like this, where you have some JSON blob, where you have information about packages, an array, there you have their name, version, and you will have more of these things in the JSON. And you want to kind of load it and work with it in a nice way. So what does nice way mean? You want to have some class which kind of encapsulates all that. You want to load the JSON and get some object and call methods on it which correspond to the JSON. So I have the packages method which accesses the array and access elements of the array and properties of the objects there. And you don't, in Ruby you could have done that with hashes, because it's Ruby, if you unserialize JSON in Ruby, you get hashes, but you don't want to do that. You want to have nice method because you hate hashes or whatever. And then you want to have a reverse. So you want to be able to, after some manipulation, serialize the description to JSON. So I will just delete this. That was just for the explanation. And let's start with coding. So in Spec, you structure the tests using describe blocks, mostly, which tell you what you are describing. And in general, it's a good idea to mirror the code you will write. So I already created the class here, system description. So I will naturally create the describe block for the class. And then I want to start with the deserialization from JSON. So implement the from JSON static method. So I'll add a describe block for that. Now, in general, you really want to mirror the structure of the code, so have a describe block for classes, having them for methods. One exception is when there is some functionality which kind of spans multiple methods, and it doesn't make sense to test one method in isolation. Then usually you just do a describe block and put in the description what kind of aspect of functionality you are testing, and go on with that. So we are describing from JSON, and we will start with something simple. So let's say we want to see if it deserializes Boolean values. So this kind of says I will test whether it deserializes Boolean values. So this already is something that can be executed by Spec. So I will do that here. And you see that it reports that based on the describe blocks, it composes a message, which actually makes sense. That's important. So it says this method deserializes Boolean values, and this is not yet implemented. So the test is missing. So let's implement the test. So we'll have some JSON. And something like this. Then we will create a description from it. And then we will test whether it contains what we wanted. So we will test that the description true value equals true, and similarly for false. So for those who are unfamiliar with Spec, this is just a syntax where you define some expectation. So you can treat it as black magic if you want. And there you say what kind of object you are testing. And you are saying it should be equal to true. This equal thing is called a matcher. And there are many other matchers than for equality in Spec. So you can test for more things. But let's see how we do. Oh. Save. Yeah, so Spec is telling us that there is undefined method from JSON in the system description class, which is kind of expected. But the output is kind of messy, so we will use colors. So now you may see it that it's actually red. So let's implement the from JSON method. So how do we do about that? So Ruby has a JSON parsing library, so maybe we can use it. Like this. And what we want to do, what we have here is we got a hash, because the JSON is object. But we want something converted into something class-like, so with these fields. So Ruby has a nice class called OpenStruct, which does exactly what we want. It takes in its initialization a hash, and then it basically creates an object which has methods corresponding to the keys of the hash. So you can use method access syntax to access that. And you can read and write all the properties. And you can still get the hash back from it. So maybe one way to implement all this would be to use this class, make system description subclass of it, and then when we have the hash, let's create a new instance of system description, which and as an argument we will just pass the parse JSON, which is this hash. So this should pretty much work. And as you see, there is one example, 0 failures. Good, it works. So what do we want to test now? So one thing there is more simple values than Boolean values. So maybe we want to test integers and strings and null, for example. So there is a question how to structure the test further. Because one thing we could do is to create a new it block for each kind of these values. But from my point of view, the values are more the same than different. So I would just adapt this block and create a slightly bigger test for all the simple values. This is kind of a decision which it's more a matter of taste than anything else. Okay, and here let's adapt the test. And it runs, it passes. So this is actually the instance where you have a test that passes. So you may at this point wonder what and to how much depth you should test here. Because what you have here is the JSON parse using the JSON parsing library of Ruby. And what you kind of doing here is actually testing the library. So this is kind of a bigger question, because you can approach tests in various ways. One way is that the test doesn't know anything, or pretends that it doesn't know anything about this code. So in that case, you would want to write quite comprehensive test, because you don't know what's here. That's called black box testing. Another approach is that the tests know what's inside and try to really test what is inside. So here the test would know that there is a JSON parsing library which probably is well tested, so you would want just to very lightly exercise the JSON parsing to really test this code, not the JSON parsing code. On the other hand, the implementation may change in the future, and you may want to have the test guarding against such changes. So maybe this is not that a bad idea to test a little bit more comprehensively than just one JSON blob. So in this case, I decided to have the simple value tests here, and maybe test for arrays and objects, and we'll see where it leads us. So there is one more thing. We have multiple expectations here at the end of the test. There is a school of thought that says basically one test, one expectation. So according to this school of thought, I would have to split this into 5 different tests. So I don't really agree with this school of thought. I am more pragmatic. So I don't think in this case where the expectations are really about the same thing, it's a problem. And actually, we will solve this problem differently, because what you can, if you know Ruby, you quickly realize that we are basically testing whether the description is equivalent to some other description by testing its properties. So maybe we can just test it using the equals operator. So I will write what I mean. Let's expect description to be equal, and it should be equal to new system description, which is constructed from some hash. So yeah, something like this, and so on. So I will just reuse this piece of code. And okay, it's still green.
Question.
Yes.
At that point, how do you know the test is correct?
Yeah, that's a good point. But you basically have to start being confident at some point, because you would have to have tests for tests. Well, one important thing is not to change the code and the tests at once, because then you could create kind of a bugs that cancel each other. So you should try to avoid that. Here I am confident enough that the test still test the same thing, so I could do that change. If I wouldn't be confident, I would do it in smaller steps, or maybe leave the test as it was, or maybe create additional test. Yeah, there are various approaches.
You can even add errors just on purpose. So, for example, change the true value to 5 or something and see whether it fails. Then if you can trust your own test, just make it fail and see whether it's actually failing.
That's also a good point, make the test intentionally failing. Yeah, so it still tests something. Okay, so let's try the serialization of arrays. So the structure of the test will be kind of a similar. Okay. So this works, not unexpectedly. So now let's try objects. And there is where the interesting part starts. So let's something like this. And what do I want to have here? So the JSON parser would just give me a hash, but as I said, I want to have a nice method access, so at this point I will probably want to have the open struct here with all the necessary attributes. And you see that the test fails. And here is kind of a diff. So what we want is to have an open struct, but we have a hash. So Spec has a very nice tooling to show this. So what do we do about it? We need to convert basically hashes into objects. So let's write that code. So it would be kind of a private static method, so I will change the syntax here to allow me to do that. And something like this. So if description is a hash, then we'll do the conversion, else just return whatever was there. So how can we do the conversion? I will write it in a really simple way. So create a new open struct. And go through all the keys and values, and key is so let's do the conversion recursively. This is actually a point where I'm kind of breaking the rules here, because this part probably isn't necessary to fulfill the test. So that's a case. If I were going strictly TDD, I would just write V here and then write another failing test which would make this. But maybe it is necessary. I don't know. Yeah, so yeah, what I do here is just fill the open struct and return the result. Experienced Rubists will notice this could have been done in a little bit more elegant way, but I will keep the code like this just to make it more understandable for most of you. Oh yeah, and we need to call the code. So here, hashes dual structs. Good. So it works. And yeah, as I said, sometimes I want to test more complex behavior, and I actually think of that maybe objects in arrays wouldn't be converted. So let's write even more tests, which will handle this complex case. So I would describe it that it deserializes complex nested structures. So what we will write here. So I said objects with in arrays. So let's have object in array here. We can just copy this, I guess. And let's add some. And we can also have arrays in objects just for completeness. So it looks like a nice JSON. And what we want as a result is something like this. Okay. So let's try the test. And it breaks because, oh, the JSON is somehow wrong. Yeah, the whole thing has to be wrapped in this. Okay, and you can again see the diff when comparing the objects for equality, and you see that objects in arrays aren't correctly converted. So let's write the test code for that. Something very simple. So it's an array. Then let's just map it through the hashes to all structs. Still failing.
There's a typo in the test. Objects versus object.
Thanks. Okay, so now it works. And then this is the example where the step number 3 refactor comes into play, because I look in the code, it satisfies the tests, and I don't like it. Because I know when you have multiple if statements, you should always ask whether case statement wouldn't do. And in this case, it would, because Ruby has a smart case statement, which allows discriminating by type via the magic of triple equals operator. So we can rewrite this a little bit. So when it's hash, then do this. When it's array, do this, else do this.
No. Remove one.
Yeah. And it still works. So now we did a very safe refactoring. I actually like it like this even better, because I like to have a simple cases first if possible. Okay, so this is the deserialization. At this point, I'm confident enough that this works. I have the test to prove it, so I would claim deserialization done. So let's have a look at the serialization. We won't do all of it, but only the beginning, just to see some other things I want to show you. So we will again start with the describe block. Yeah, actually, yeah, here we should have a dot instead of a hash, which is a convention for static methods in Ruby. Here we should have a hash, because this will be instance method to JSON. So, and it makes sense for the test to kind of mirror the structure of the deserialization tests. So let's try the simple values first. So how would the test look like? So we want to have some description with simple values. We will serialize it. And then expect JSON to be equal to something like this. Okay, makes sense. All right, somewhere.
The coding of the JSON.
Yes. Right. And we will see. So, the first thing we will see, of course, the test will fail. We didn't implement the functionality. And we will see that instead of a JSON, we get some very weird string. So knowing Ruby, we can assume that this is what the default toJSON method does on the system description instance. It just calls the inspect method and produces the result as a string. So that's not what we like. So let's implement our own toJSON method. And what can we can we do is just we can, because this instance is open struct, we can extract the hash from it and convert it to JSON. That might be a very simple implementation. So better, we see that the actual output is a JSON, but it's formatted differently than our expected JSON. And because we are testing basically for string equality, the test still fails. So we have a couple of possibilities what to do here. One is, of course, adapt the test case to be exactly to have exactly the format of the emitted JSON. But that for one, it would be ugly to have something like that in a test. And B, it would make the test very fragile. Because whenever we would, the toJSON method on the hash would change, or if we would change the JSON implementation to say something more performant or whatever, the output could change. We don't really care whether we have spaces there or not, and whether we have new lines there or not. We care whether this JSON is semantically equivalent. That's the important point we want to test here in this test. So, one thing how to implement this would be to write something here, some kind of a loop or whatever that would, or something similar which we wrote in the first test in the beginning, testing for the properties or something like that. But because we want to write another test in very similar way, we know already that this probably wouldn't scale and would lead to ugly tests. So what we can do is define our own matcher. That's possible in Spec. If you are not satisfied with matchers that are already there, you can define your own matchers. And every testing framework which is worth the name of testing framework has some capability like that. So let's not test for equivalence, but say something b equal JSON here. And if you just look at the test, it makes sense. You expect JSON to be equal to this JSON. That sounds right and is descriptive. So that's what you should aim for in the tests. Not put just some mess of code that tests what you want, but also the test to be descriptive. So somebody, when will read it, will understand what the test really is about. So what we need now is the implementation of the matcher. So I cheated a bit. So I already have the implementation in hand. I put it in the helper file, which is automatically, or which is not automatically, but loaded here at the beginning, because writing the matcher is just a tedious task. So the matcher looks like this. It's just some call to define a matcher with the name b equal and JSON. And there is a match block which does the actual comparison. So two variables are in scope, the expected thing and the actual thing, which you are comparing, kind of. And what we do here is that these will be strings. So we just parse them using the JSON library and test the result for equality. And because JSON parse produces a hash, or array, or nested structure of these, and both arrays and hashes have equality operator defined in such a way that it behaves reasonably. So two hashes with the same keys and same values are equal, and arrays with the same elements are equal, and so on. This will work nicely. So I messed up somewhere. Let me have a quick. Oh, equivalent JSON. Okay. So as I write it over and over, I get two shorter names, obviously. Okay, green passes. Nice.
Does it still fail when it should?
Well, we can try it. Yes, it does. So, at this point, we've done, wrote the code, wrote the test, and it passes, so we now look at the refactoring step. And the refactoring doesn't mean you should only refactor the code, the implementation. It also means you should look at the tests, because tests are also code, and as with other code, you want to remove duplication and keep all things tidy and so on. So here, undoubtedly, you notice that the description and the JSON are same as in the first test. So it probably makes sense to extract them. So RSpec has a syntax for that. So we will define kind of RSpec-ish variables. So let's have a JSON simple here. And this syntax basically defines a method of given name, and there is a block. And when the method is called for the first time, the block is evaluated and the result is cached. So this is important when you have some kind of data which, I don't know, is there's an object that's created in a database or something that's expensive to create, but you use it just once or twice in the tests, then this becomes handy. Yeah, so we will have the JSON simple and description simple. And let's adapt the tests. So we parse JSON simple and expect we will get description simple, and the same, similar here. Okay, so I must have done some typo, something. Or yeah, it needs to be defined on a level above this, because it's used by both the describe blocks, so it can't be defined only in one of them. Okay, so tests are green. I'm pretty confident if I change something here, it will break. And at this point, you can imagine that I would write similar tests for other pieces of JSON serialization. I would extract more descriptions which are shared and more JSON pieces which are shared, and the tests would actually look very simply. There would be just some fixtures, basically, static data, and then would be few blocks like this, which can be understood very, very easily. So I won't do this here because it's just mechanical work, and you already seen it done once. And I would now look at yet another thing. So assume that we have this working, and now somebody comes and wants to validate the JSON and says, okay, let's have a set of validators in the description, and when the from JSON method is called, these validators are called on the JSON which is loaded, and they can do whatever they want. And well, if they encounter something they don't like, they will just throw an exception, and if the code is okay, the JSON is okay, they will just return something or not return anything. So let's show how we would start developing such a feature in, again, TDD fashion. So the first idea is when we would have the add validator method, well, we should probably start by describing it and writing its tests. So it adds a validator that is executed when deserializing. Sounds reasonable. So we will call the add validator, and we will add some validator. That's obvious. And it's also obvious that we will want to do some deserialization to test that it's executed. Say something like this, just empty JSON. So how do we now define the validator, and how do we verify that it was executed in the from JSON method? There are basically two ways how to accomplish that. The first would be to create a class now. I didn't explicitly say that, but the assumption is that the validator would have a validate method, which is called. In Ruby, you would probably do it a little bit differently if you were doing it in very Ruby way, but I want to show the dilemma I will just talk about, so let's assume this design. So how do you test the validate method was called? One way is to create a validator class, which includes some state. And in the test, we would check that the validate method would change the state. And we would just check that the state was changed in the way we want it. So there would be, for example, Boolean flag that the method was called. That is one thing. Another possibility is to use test doubles or mocks. There is a little bit confusion in terminology, so I don't want to go into that. But the general idea is that you will have an object which will have kind of a expectation that its validate method is called. And when this expectation isn't fulfilled, the test will fail. And our Spec has support for these mocks, so you can easily mock the validator and test that. So let's write such a code. And then we will discuss a little bit. So validator is double, and we expect validator to receive validate, and we want to also test the arguments. So when we parse empty JSON, we should get, say, let's operate on the JSON level, so we will have the empty hash. So this is a valid test, and it fails. There's undefined method add validator. So let's add it. So we said we have multiple validators, so let's add this here. Validators, put a validator there. And here let's just go through them and call the validate method. Each. Okay, it's green. Good. So now I did one sin from a TDD, pure TDD point of view. Could you point out what sin it was?
Let your test fail first, and you didn't call the validate method.
Yes, I didn't. Well, I had it failed at the beginning. It failed with no add validator.
Try it.
Yeah,
It would fail if you wouldn't validate it. If you wouldn't call the validate method.
Okay, that's one point. Is there another thing which I shouldn't have done? This test actually doesn't say anything about multiple validators, but I already assumed that and added code for handling multiple validators. So if I just added a validator and assigned here instead of appending to an array and just called validator validate, this would pass the test already. So I didn't write the minimal code which would pass the test. I kind of looked into the future. So either I should have done the test a little bit differently, put multiple validators there, and multiple expectations, or I should have implemented the simple code and then add another test and refactor from pure TDD view. So that's one thing. Another thing is that it's questionable where this test actually should lie, because I added into the description of add validator method. And so yes, I implemented that method, but I also implemented some code in the from JSON method. So it also tests that the from JSON method executes the validation. So there are various ways how to deal with this problem. You could put the test into either of the describe blocks, which kind of isn't that clean because it tests more methods. You could duplicate the test, but that's kind of a pointless. You could also decouple the testing of the execution from adding the validator. So for example, you could have a accessor here to the validators variable, and then only test that after adding the validators will return the just added validator, something like that. But that kind of smells because then you would add some code just because of the tests. And in general, that's not a very good thing to do, because what you should think is, think about the API from the point of view of user. Is it right that the user should have access to the validators? Maybe it is. If it is, then it wouldn't be a problem to write such a test. But if you think the validators accessor shouldn't be in the description class, then this wouldn't be the right approach. So what I would probably do here is actually do the thing I talked about at the beginning. Do not adhere strictly to the structure of the methods in the class, but put this as an extra block, testing validation in general. So we just describe validation and then rewrite the description a bit to reflect that it tests the add validator method adds a validator that's executed when deserializing, something like that. So this is exactly the case where the two methods are so coupled that it makes sense to test them together. So I talked about how tests can be a documentation. So I will now show it to you using RSpec feature. Normally RSpec just puts these dots as it completes the tests and prints out the summary. But you can use different formats, and if you use doc format or documentation, it prints the structure of the tests in a way that reflects the describe blocks and it blocks and so on. So this is exactly how you could learn what the system description class does. Yeah, from JSON deserializes whatever is in the JSON, add validator adds a validator, and so on. In such a simple class, it probably doesn't add that much value because the method names are very descriptive and it's quite obvious what the class does. But more complex your code is, more value this has. And yeah, there are people, some of them sitting in my office, who really do this. So they really run the tests first and look at the tests, and try to understand how the code works from this kind of output. Yeah, so this was the example. If you want to learn more about TDD, there is this book, Test-Driven Development by Ken Beck, which is like the book about test-driven development. I can recommend it, I read it. There are probably other books, but I haven't read any other book about TDD, so I won't recommend it. And there is, of course, a lot of stuff on the web. So I would encourage you to look there. And also, I have a Twitter, and occasionally because I'm interested in TDD as such, I occasionally post links to articles and discussions and so on about TDD. So maybe if you follow me, you will get some supply of nice content. So that's all what I wanted to tell you. And 2 questions. Yes.
The test being 3 times as big as the code itself and also being rather complex, doesn't that lead to a situation where nobody wants to test the test because they are not understandable anymore? Repeat the question, please.
So the question is that the test was much longer than the code. So whether that doesn't lead to a situation where the tests are too complex. Did I get it right? Or nobody doesn't want to touch the tests because they're complex, right? Yeah. So yeah, that's a tough one because there is a lot of talk today about the code to tests ratio, and everybody has his idea what the ideal ratio or the maximum acceptable ratio is, and what makes sense and what doesn't make sense. So I would say it goes back again to the level of confidence. So if you are confident enough about your code, you won't actually have that many tests because you won't test all the stupid things. Maybe you would decide that you trust the JSON parsing library and just put 1 test there, not 4 as I did. And So I would say in most projects you would have a ratio of 1 to 1.5 to 1 to 2 maybe, something like that. That's my experience. Now, there are projects which kind of require a higher ratio. For example, when I did the YCP killer, which included just a transpiler, so it transformed basically some abstract tree into another abstract tree. So the tests created pieces of the trees and tested that the conversion was right most of the time. And the setup, the just expressing the trees, the situations where you have some code which is in some scope, which is again in some scope, and the compiler does this or that in the situation, naturally led to high ratio of test lines to code lines, because the setup was kind of complicated. But at that, yeah, I didn't like it. But on the other hand, I wouldn't be confident without these tests. So I accepted that as a kind of a price for being really confident that the compiler does what it does. So and another aspect of this is that you really should treat tests as normal code. So apply all the rules you apply to the code about naming, about proper encapsulation, about modularization, about not repeating pieces of code and so on to the tests too. And the test code usually isn't the nicest code. You're right, it tends to be a little bit tedious. It's kind of a linear. There is not much structure in it. And there tends to be some repetition which is hard to abstract away. That's all true. But I don't think tests, when you do TDD right, need to be complex to such a degree that you don't want to touch them. That's at least my experience. So, another questions?
So you said in the pure TDD model, you always run the tests in between changing the tests and changing the code, right? But it's pretty easy to forget to do that unless you have something like Dart, which automates that.
Yeah. So yeah, this is, as I said, the question is that it's easy to forget to run the test between the changes in code and tests. So I didn't want to go into tooling in this talk, as I said at the beginning. So yes, it's possible to have something like guard, which is basically a tool which runs in the background and reruns the test automatically when you save files. It watches the file tree. I yeah, personally never found big need to run such a tool, but a lot of people do that. So apparently it's useful for them. So yeah, if it's useful for you, use it. So there was another question. So the question is that I said that one of the benefits is that you have tests, and what's the comparison with, say, extreme programming, where you also at the end you will have tests. So as you may know, extreme programming was actually also created or co-created by Kent Beck, the same guy who is responsible for TDD, and so extreme programming is something bigger. There are other techniques which are kind of embedded in this work, in this methodology. So there is this idea of pair programming, and there is some idea how to organize the work and even how to organize the workspace and so on. And it's true that you have tests there also as part of the methodology. And I would say that TDD is was kind of extracted from XP. I think they basically it's there, it's part of XP, but it kind of was extracted and it's kind of a thing on its own now. So that's how I view the relationship. So if you do XP, you will end up with the same thing pretty much as TDD code-wise. Yes?
How exactly TDD is different from BDD? Because one more question I have is there's something called as acceptance test development, ATDD. So is it something related?
Okay. So the first question is how is TDD different from BDD? So the usual joke is, yeah, the difference is the first letter. I actually have a hard time understanding the difference myself. BDD, as I saw it used, is often used in context of a higher level tests than the unit tests. Yeah, good. BDD is behavior-driven development. So the idea is that you specify the behavior of something you want to implement and then implement it, which is similar to TDD. And actually, Spec is labels itself as a BDD framework, not TDD framework, because you describe these behaviors in the describe blocks and it blocks. So the description is important part of the tests, which is not the case in other testing frameworks where the focus is more on the code than on the structure of the test and the descriptions. So, and the term BDD is most often used by people writing acceptance tests or functional tests with Capybara or whatever other frameworks, which work on a more high level. They don't test methods, classes, and so on, like with TDD, but they test whole functionality. So, yeah, it's more black box, more high level. But I never saw exact definition of BDD, TDD, and how exactly they differ. Or rather, I saw several and they conflicted. So I don't have a very good answer for that. And the second question was how does it relate to ATDD, acceptance test driven development? To be honest, I don't have an idea because I don't know what ATDD is. Okay. Another question?
So very recently there was discussion, also DHH is keynote, like here's a concept, this TDD dev, and that's sparked a conversation with Ken Beck and other people. So I was wondering if you could maybe summarize that from the people like me who have enough time to.
So the question was to summarize the discussion about whether TDD is dead, which was started by DHH on RailsConf this year. So DHH is the creator of Rails framework, and he had a talk where he kind of bashed TDD, and his points were that he basically mostly attacked the point about that TDD improves your design of your code. Because to him, it seemed that when he tried to do TDD properly, he introduced more complexity to the code and he wrote it differently than he would without. So his idea was that it leads to worse code and just because of the tests. And he kind of thought whether it wouldn't be a better idea to test on a little bit higher level than on the level of unit tests, test more on a bigger blocks. Also, he basically didn't like mocking, again, because if you mock a lot, you will end up with a lot of setup code. So he was rather fond of the idea of tests which go through the whole stack. The mocking in Rails is often used, for example, to mock the database, so you don't have to work with the actual database, but you just mock it out, and that way you are not dependent on it, and your tests run faster because of that. So it started the whole discussion, and they had a kind of podcasts with or Google Hangouts with Kent Beck and Martin Fowler, who is also a very important person in software development. And they discussed all these ideas there. So if you are interested, I would encourage you to find that. Just enter TDD is that Fowler or something to Google, and you will find that. And I also tweeted about that a while ago, so you can find it in my feed. And there they discussed all these ideas. And I have to say the discussion was kind of, well, Ken Beck didn't know Rails, so he was, from my point of view, it looks like he discussed on more abstract level than DHH would probably like. And I don't think there was any clear conclusion from the discussion. But I felt that the discussion was really needed, because I also had the issues which DHH pointed out, and there is a lot of people thinking about all these things, and maybe there are some best practices which will emerge from this, which would help guide people writing Rails code to do TDD in a better way. And maybe it will also lead to some changes in Rails themselves to allow that, or maybe not. Because one of the things that I would say was important, but nobody actually mentioned it in the discussion, was that Rails is adjusted or designed for testing. There are unit tests, there are functional tests, and so on. But it's not especially designed for TDD done properly. So, for example, there is a lot of global state, there is a lot of automatic configuration loading, and all this stuff, which in the tests kind of requires you to do global mocks and requires you to to write code or tests which have complicated setup and maybe are not very performant if you don't mock everything and so on. So seeing other frameworks, even outside of the Ruby world, I think it's possible to write framework more in a way that TDD would be possible there better. So that's what I saw in the discussion, kind of not mentioned, but very obvious. It was mentioned in like a few places and some comments and blog posts, but not in the discussion, core discussion itself. Yeah.
So in a real world scenario where the test code itself could be very used, who should maintain the test code here? Like the developer who writes the production code, or like we should have separate software engineers and test who should maintain the test code?
So the question is whether developers should write code themselves or somebody else should do that, because the test could be very big. Well, in TDD, the idea is that the developer writes the tests. And the reason is obviously that you have this quick feedback cycle, so you can't have this quick feedback cycle with other people involved. That would be quite hard. And another thing is that tests actually help you design the code. I didn't mention it in the benefits, but I probably should have. The idea is that the test is your first client of the class, of the method, of whatever. So in the test, you basically write the code the user of the class or method would write, and you can very easily see, oh, this is not something I would actually want to write as a user of that class. So then you go and tweak the test until you like what you wrote there, and then you go implementing it. So it helps you with API design, it helps you with structuring objects and so on. That's another benefit of TDD. And again, for this you need a fast feedback cycle and so on, so it's hard to do that with multiple people involved in the process. So I would say it's possible to involve multiple people in testing when you do, say, functional testing or integration testing. So one guy writes the integration tests, which tests some bigger chunk of functionality. Say a command line app, it tests it from the command line, like executes it really and observes that it did something, and then somebody else writes the implementation. There, yeah, maybe, but not in unit testing. So another question? Okay, so if there are no questions, then thanks for attention, and hope to see you in some other lunch and learn talk. Thank you.